what was peculiar and very interesting that rotavirus A is virtually found in all forms. It's really hard to keep it out. I mean, impossible, and it's really travels very easily between different facilities. So there is also a lot of evidence from human clinical studies that rotavirus A can spread via aerosols, like airborne, and can cause multiple extraintestinal issues, including neurological and issues with the liver, pancreas, including now it's even thought that it is one of the contributors to the development of T1 diabetes.
Welcome, everybody, to another episode of Swine Canada, brought to you by Genetics. I'm Aline Remus, your host, dedicated to bring you the latest insights and discussions in the swine industry. Get ready and expand your knowledge and stay ahead with today's episode. Today, we're turning our attention to something that is a tiny microorganism, persistent and often underestimated: porcine rotaviruses. These viruses are among the leading causes of diarrhea in young pigs. It can silently circulate within herds, impacting health and growth performance. To help us to better understand these viral culprits, I'm joined by Dr. Anastasia Vlasova, Associate Professor in the Center of Food Animal Health at Ohio State University. With a strong background in virology and animal science, Dr. Vlasova is a global expert in rotavirus infections, pathogenesis, and their implication in both swine health and biosecurity. Dr. Vlasova, welcome to the show and thank you for being here.
Hi, Lynn. Thanks for having me. I'm happy to share whatever I can about rotaviruses.
Dr. Vlasova, could you tell us a little bit about your background and how you came to work in this field?
So I should start from the very beginning. I am a third generation researcher or veterinarian. So it started with my grandparents. I think my maternal grandfather was the first veterinarian, and so it kind of runs in the family. Second, I really early on noticed that I really like finding answers to questions. So this combined, we got what we got. So it was no-brainer for me at the end of high school where I was going to go. I chose the university that deals with most of veterinary sciences, biosciences, veterinary medicine, and biotechnology. So I got my master's in DVM from there. Then I continued with PhD also in Russia, Moscow. And at that time I was working for the Institute of Virology, and my focus for my PhD research was also porcine viruses, but specific for Russia and Belarus at that time. So I was working with classical swine fever virus and PRRS, porcine reproductive and respiratory viruses, that are big issues there. So while you have so big issues on hand, nobody worries about rotaviruses. But I think now they're recognizing it more and more, even back home in Russia. So yes, and then I came as a postdoctoral researcher to the Ohio State University to work with Dr. Linda Save, who was the world's famous coronavirologist, and also she was doing a lot of research on rotaviruses and caliciviruses, and mostly specific for swine. So, and that kind of sealed the deal for me. I knew the field I wanted to continue in.
That's a very impressive long history and very close relationship with the topic. Thank you for sharing with us.
Absolutely.
Swine Veterinary Partners comprises 4 well-established clinics across Canada: Precision Veterinary Services, Premier SHP, Demeter, Ontario, and Demeter, Quebec.
I'm very happy to have you with us today. And I think we can start by the basics. What are rotaviruses and what diseases do they typically cause in pigs?
So first, what I like to emphasize that porcine rotavirus is not just one rotavirus. It's actually 4 different species of rotaviruses. So they are considered officially established by the International Committee for Classification and Taxonomy of Viruses, and they include rotavirus A, rotavirus B, C, and H. H is the emerging species, and it's much less studied than the other three. So I will be focusing mostly on A, B, and C rotaviruses. So to cover the basics, rotavirus A is found virtually on every farm, swine farm worldwide, and in the US specifically. So it's mostly affecting weaned piglets. It becomes the major contributor to the post-weaning diarrhea. However, up until then, it doesn't cause major issues because most piglets are protected by suckling status. So rotavirus C, however, actually affects primarily neonatal suckling piglets. So it's now recognized as the major sole cause of neonatal pig diarrhea. So, and finally, rotavirus B, it's more similar to rotavirus A. It's affecting weaned piglets. However, it's found less frequently. For example, A and C, rotaviruses A and C are found on most farms. We've just recently conducted another study, actually it's still ongoing, checked 6 swine farms, research and commercial in Ohio. All of them had rotaviruses A and C, but only 3 had rotavirus B. So what's important to know also that rotavirus B, the time that it's shed is much shorter, so it's much easier to miss. So maybe it's less prevalent, or maybe it's just much harder to catch. So, and now I will go one virus by one. So rotavirus A, so as I mentioned, it causes primarily post-weaning diarrhea. However, recently the attention was to the extraintestinal replication of rotavirus A. Everybody knows that rotavirus A, yes, causes havoc in the gut and causes diarrhea, makes piglets sick that way. But what was peculiar and very interesting that rotavirus A is virtually found in all farms. It's really hard to keep it out, I mean, impossible, and it's really travels very easily between different facilities. So there is also a lot of evidence from human clinical studies that rotavirus A can spread via aerosols, like airborne, and can cause multiple extraintestinal issues, including neurological and issues with the liver, pancreas, including now it's even thought that it is one of the contributors to the development of T1 diabetes. So, and many other organs are affected. So we are conducting one of the studies right now to actually gather the field evidence if it is indeed capable of airborne spread, and if it is a significant contributor to respiratory or any other extraintestinal illness. So in that study, we were sampling multiple farms. On those farms, we are sampling suckling and weaned piglets, and we are checking the presence of rotavirus A in the gut, in the extraintestinal tissues, including the lung, and we are trying to associate it with mortality and the presence or absence of other pathogens, including respiratory. So at the same time, we're testing the same associations for rotavirus C, and the current evidence we're getting that rotavirus A has increased presence in the respiratory tract, more so than rotavirus C or rotavirus B that we're also finding. And there is a possibility of it contributing to the generation of respiratory illness because, for example, on some farms, we are finding the significantly strong association with respiratory disease outbreak in rotavirus presence rather than gastrointestinal. So we're trying to detangle all of that right now.
So you're telling me that you can have rotavirus A in any farm? Like all the farms now have it? It's considered endemic. There is anything that we can do to prevent or good practice to deal with it?
That's an excellent question. I think, yes, rotavirus A, at least, is considered endemic. I think it would be overly ambitious to talk about preventing it right now. I think it's unachievable dream for right now. But I think what we need to focus on is trying to reduce viral loads whenever we can. And that is why we're conducting this research, because we're trying to see, okay, are the current biosecurity measures adequate for rotavirus A, considering that it in fact may be spreading via aerosols or it becomes airborne, and we're treating it just as a regular enteric pathogen. So if it confirmed, so we need to completely revisit our biosecurity standards. But yes, as it's of right now, it's everywhere. We have failed to find any form without it. And same true is for rotavirus C. We're not finding any forms free from it. Rotavirus B looks like it's less prevalent. In rotavirus H, for example, we didn't find during our most recent study anywhere.
Are these three rotaviruses very distinguishable among them?
Yes, so they are very different. They, of course, they're all rotavirus. They belong to the same viral family, but biologically they're very different. So, for example, rotavirus A is a master of suppressing host immunity. It regularly replicates in several cell cultures, and MA104 being one of the most robust. So rotavirus C and rotavirus B are non-cultivable. You cannot propagate them in any cell culture. And that creates a lot of problems, in terms of studying their pathogenesis or generating vaccines or doing anything to prevent them or control their spread. So another interesting observation, besides not being able to grow in a cell culture, that there's at least the common belief right now is that there's very limited cross protection between these species. They used to be called groups, but now they're called species. So, for example, if piglets had rotavirus infection when they were suckling, after weaning, they will get rotavirus A. It's very likely that they will not be protected by pre-existing immunity against rotavirus C.
So actually, a sow can be vaccinated by rotavirus, and it is not ensure then that the piglet won't not get it? Or am I going too far with it?
No, you're going in the right direction. So there are vaccines for rotavirus A only, the only cultivable rotavirus. And for that virus, we have vaccines. They're commercial vaccines. They're live attenuated or killed. And on many farms, at least in the U.S., it's a common practice to vaccinate sows before they give birth, and then piglets should be protected. And that is happening because most of the suckling piglets are protected against rotavirus A. However, what we don't know if this immunity is not strong enough, lasting enough, or what. But after weaning, maternal antibodies decline. Active immunity probably not developed yet, and piglets become sick from rotavirus A. Generally, diarrhea develops not only because of rotavirus A infection alone, but because of multiple pathogens infecting at the same time. Quite often, E. coli is another contributor to post-weaning diarrhea, and so on and so forth. And that's when rotavirus A becomes a big problem. But by that time, rotavirus C already does not cause major issues. We did see, at least on one farm, an outbreak in weaned piglets associated with rotavirus C, but it's less common.
This makes me quite scared because, I honestly don't see, in my view, a better way to prevent than vaccines. So if this is still such a difficult preventive action, and that is what seems like very hard to prevent rotavirus. What is our best chance to deal with them? Or I don't know, like if we cannot really have free farms, can you have low-level infectious farms? Can you expand for us, because to help us to see a bright light maybe in the subject?
Yes, I didn't mean to scare anyone, but the approach should be probably comprehensive and stepwise. As you mentioned, first we need to think about how to reduce viral load, how to have cleaner facilities, and so on and so forth. So for that, again, vaccines, of course, provide an excellent protection when they provide it, when you know what genotypes of rotavirus A, for example, circulating, because everybody should know that the current vaccines are developed against two genotypes, G4 and G5. However, since they were commercialized, many more genotypes of rotavirus A emerged, including G9. It's the worldwide most prevalent genotype right now in pigs, and it is also emerging in humans. So first, I think vaccines are needed. Second, they need to be updated. So it's a constant process of optimizing, checking what is in the farms and what is still missing in our vaccines. Second, in case of rotavirus C, because rotavirus C is so pathogenic in suckling neonatal piglets, it is very likely that, similar to some human rotavirus A strains found in India, it somehow evolved to benefit from some maternal milk components, because otherwise, in the piglet gut mostly filled up with maternal milk, it wouldn't be able to survive if it wouldn't adapt to that. So, and we are thinking that within the maternal milk composition, we need to look for answers for this rotavirus, because we are hoping to conduct another study where we would be looking what contributes protection against at least rotavirus C diarrhea, because when we find, for example, sows with rotavirus C positive piglets with diarrhea and then without diarrhea, we assume that the second group, of course, without diarrhea is somehow protected. And we think it's all coming with maternal milk. So it produces some components that are protective, while other animals do not. So we're now proposing in one of the studies to understand the maternal milk composition in terms of its milk oligosaccharides, microbiome, and short-chain fatty acids, and see which ones are protective, which ones predisposed to increased rotavirus C diarrhea. So as of right now, we cannot talk about designing classical vaccines for rotavirus C, because it cannot be propagated in cell culture. So it means you cannot do serial passage and attenuation of the virus and eventually making it into a vaccine. So our approach in this respect is to try either use non-replicating vaccines based on virus-like particles, those viral particles without the genome, that provide all viral antigens but that cannot replicate. Such vaccines are great to boost the immunity, but not to prime. So for efficient priming, you still need something replicating viral vaccine. So, however, it may be still a feasible approach for because most adult swine, they are already exposed to rotavirus C. So maybe all we need is to boost the immunity. So in one of my projects, we're trying to do that. An alternative approach, we're trying to utilize rotavirus A reverse genetics system, which is very robust. We established a reverse genetic system in my lab for rotavirus A OSU strain, and that strain is characterized by remarkably robust replication in vivo or in vitro, in any cell culture, in piglets, you name it. It does it better than any other porcine rotavirus A strains that we know. So we established the reverse genetic. We can rescue all kind of mutants, even carrying completely heterologous VP4 proteins. And VP4 protein is the major receptor binding protein, surface protein in rotaviruses. So we are trying to incorporate rotavirus C, at least immunogenic domains or complete proteins, surface proteins, into rotavirus A reverse genetic system and see if we can create a chimeric replicating vaccine. So if that works, if those chimeric viruses are rescuable, that probably would be even better vaccine than non-replicating.
That is very impressive. So what I'm taking from that is you have to characterize what you have in your farm. You have to use new ways to produce vaccines. In other words, we need to up our game against rotavirus, right? And it seems that is what your lab has been doing, and is much of research that you have been conducting, which is very good news for us. So now I am calmer. Thank you. So in the what makes, I think you actually already touched a little bit this in the subject, but what make rotavirus then so challenging in virology management? I understand that is the way they replicate so far, but is there anything else that you'd like to add?
Yeah, I think I tried mentioning in the beginning that rotavirus A is a master of immune evasion, or in simple words, it can counteract the host immune responses. And there are at least 3 viral proteins: NSP1, non-structural protein 1, VP3, viral protein 3, it's a structural protein, and another structural protein, VP6, that specifically downgrade different innate immune response factors, different interferon stimulating genes and others. So that allows them to replicate, to survive, to make progeny without evoking much of the host immune response and being eliminated too soon. So in that respect, we know much less about rotavirus C and rotavirus B. So far, we did conduct a transcriptome response, this differential transcriptome response comparing rotavirus A and rotavirus C. In rotavirus C, seems to be upregulating so many more immune genes in any host cell. We were looking specifically at porcine enteroids, mini guts. So it does not seem to be such an expert in downregulating the immune response, but apparently it evolved some other mechanisms to survive, such as like adaptation to the neonatal gut more than rotavirus A.
That is very interesting. So it also gives, in the end, it gives opportunity to opportunistic, other opportunistic bacteria. You mentioned E. coli and others. Can the fact that one farm has a presence of rotavirus end up being a cause for other outbreaks?
Yes, again, especially going back to rotavirus A, because it has such a prominent immunosuppressive effect, it definitely provokes secondary infections and help other pathogens like a Trojan horse, So yes, that's why I think it becomes a big problem post-weaning when all other pathogens already attacking the piglets, and rotavirus A is definitely helping them open the floodgate. So.
Yeah, how can we detect? How can you make it because you characterize for us that we have to have a vision of what we have in our farm. So one, how do we characterize which rotavirus we have, and how do we monitor these outbreaks?
Yeah, I think right now the best approach is just to collect fecal samples and apply, quantitative or conventional RT-PCR. It's molecular diagnostic method. It's very, very, very sensitive, very fast, and pretty accurate. So, and also you can combine it with sequencing to genotype to know, like, okay, it's not good enough to know if it's just rotavirus A. You also prefer to know what genotype it is to see whether or not your vaccine is going to be protective, or why this strain of rotavirus A, for example, causes more associated with respiratory illness in suckling piglets, and the other one is more associated with diarrhea in weaned piglets. So I think these are very powerful tools. I think the scientific field mostly moved away from serotyping, because previously those were serotypes when they were using specific hyperimmune or just anti-sera against certain strains of rotaviruses. However, what was noted, while for rotavirus, for all rotaviruses, a dual classification system was used for decades. It includes classification by two surface proteins, VP7 and VP4 that I already mentioned. They independently induce neutralizing antibody production, and they're definitely most important for protection. So G genotypes are derived from VP7 because it's a glycoprotein, the first letter G, and P types or P genotypes are derived from VP4, it's protease sensitive viral protein. So the classification system best established again for rotavirus A, but they also being developed now for rotavirus B and C. So when you classify these viruses, so before they used to produce anti-sera that would recognize each one of those pretty much types. So, but when genotyping became more prevalent, what was noted that G genotypes and serotypes almost always match, while that was not the case for P types. Genotypes and serotypes would not match quite often. So, for the most part, that serotyping system was abandoned and almost completely substituted with sequencing and genotyping. And that system is constantly growing. There's more and more genotypes discovered every year. And I think actually currently used vaccines and control approaches contributing to further diversification of these genotypes. So,
unfortunately, we're heading towards the end of our episode. So, for those that are at home, have you dealt with rotavirus outbreak? And what was your biggest lesson? Drop us a comment and share your experience with the community. You can also leave questions to Dr. Vlasova. We can maybe invite her back to answer those questions and discuss more with us. Before doing that, I actually just want to, I'm going to do a quick question and ask her a quick answer for a more practical application of that. How can producers distinguish rotavirus from other causes of neonatal diarrhea, such as E. coli and Clostridium?
I guess the most reliable way is, again, molecular diagnostic combined with culture approaches. I mean, viruses, of course, you will not see on a bacterial culture, but for bacteria, you can isolate and classify them. But I would say molecular diagnostic probably is the fastest, the most reliable as of right now. And if you want to talk about past exposures, of course, it's going to be a serological diagnostic.
So in terms of clinical signs, there is no real difference between the diarrhea that's caused by rotavirus and E. coli or Clostridium. They're pretty similar. You could not distinguish them just looking at clinical signs.
So if you talk about diarrhea caused by different rotaviruses, it's very similar, other than looking at different age groups and considering all the other information. As for some bacterial diarrheas or even coronavirus, for example, diarrhea, it can be more severe than rotaviral diarrhea. Quite often, most of the times, rotavirus alone does not cause bloody diarrhea. So, but for example, coronavirus or E. coli, they can do that. So, yeah, there are some certain things for to consider for differential diagnosis. So, but yes, the rotaviruses, they do cause very similar signs, clinical signs, and pathological changes. And they're not as severe as those caused by some bacterial and coronaviruses.
It's time for our famous three.
Thank you so much. Now we're going to head out to our three famous questions. And I would like to hear from you. What is your favorite virology or pig health related book or resource?
So I generally like going to disease of swine because they cover it all. Sometimes we go for field virology, but field virology, they're about all viruses, not just swine. But I think diseases of swine is the most common resource for us.
And what's your favorite book or activity outside science and research?
That's a good one. Besides the research, I have 3 kids and they don't leave much time for much reading. But, I used to really love James Herriot. Are you familiar with that book? And I almost became a veterinarian. But in that book, if you read it, he's a veterinarian and he dealt with a lot of infections. And that kind of also inspired me. That was my other passion. And I think still remains like whenever I get a chance, I read that. And actually, I was very happy to see my 10-year-old reading it recently.
What do you think sets successful professionals aside from those that are not?
If you really want to help the swine industry in this case, first you need to know the major challenges and issues in the industry. It means very good communication is critical. To be able to listen and, to understand what they need, what bothers them, what piglets are sick with. The other things, I think you need to be innovative, kind of what were you mentioning before, that's an arms race. The viruses, you can never think about those infectious diseases being something static. They're constantly changing. They're trying to outrace you, and you have to do the same. You have to be one step ahead of it. So, which means all the innovation, all the knowledge you can gather and combine and bring it all in one, and be as comprehensive as possible, because you can't think about one thing, but for example, rotavirus, but what about all other pathogens that are contributing? So, in-depth knowledge, innovation, and really, really knowing your field.
That's some very impressive advice. Thank you. So that's a wrap for today's episode of Swine Canada, presented to you by Wise Genetics. Huge thank you to Dr. Anastasia Vlasova. Thank you so much for sharing your deep knowledge on rotaviruses with us and helping us to understand better and manage this disease that seems so widely spread in swine.
I wanted to thank you. It's my pleasure to share this knowledge. I think it's very similar to what you're doing in Canada with.
Yeah, thank you so much. Actually, it was really helpful. And for those that are at home, if you found this episode valuable, please make sure to subscribe, leave a review, send questions. Your opinion is very important for us. This is Aline Rimus, your host, signing off for today.